Hey, welcome back. So in this video, we are going to see some patterns instead of memorizing formulas. Um, that's gonna save your time and your energy memorizing these formulas all the time and getting confused in the end. So let's do a quick recap of differentiation rules. Some of these formulas of differentiation rules. A derivative of constant function is zero, and there's a power rule. And then we have a constant multiple rule, and then natural exponential function rule, and then sum rule or difference rule. Okay, let's look at this first very example. We have this function f of x is equal to 2 raised to the 240. So the difference, so the derivative of this function is going to be, guess what, it's a constant function, right? So it's going to be 0. Now let's look at this next function f of t, which is equal to this, and find the derivative of this function f of t. Now just looking at this, so what are you saying now? I can definitely see power rule being applied here in this function, right? And we can already assume this is t raised to power 1, right? Okay, let's solve this then. Applying the power rule here, right? X to the n is equal to n times x to the n minus 1. Okay, so 2 times t3, right? You can also write as this to simplify the expression if you want. Um, like, okay, here we go. We see two things here, right? We are saying constant multiple rule and power rule, right? So the best way to simplify this expression is as this, applying the constant multiple rule here, right? So derivative of 2 to the cube is going to be 2 times derivative of t, right? And then same thing as for this one, 3 times derivative of t the square minus 4 times derivative of t. This is simply going to be 2 times derivative of t cube. Now applying the power rule, right? It's going to be 3 times n minus 1. So we are going to deduct minus 1 from the power. 2 times 3, and then we are left with 3 minus 1 minus 3 times t square. Derivative of t square is going to be 2, t to the 2 minus 1 minus 4. Derivative of t is going to be t to the 1, right? So this is times 1, and then t is going to be 1 minus 1. So what we are left with is this. We are left with 2 times 3 is 6. T to the 3 minus 1 is 2. Minus 3 times 2 is 6. And t to the 2 minus 1 is 1. Minus 4 times 1 is 4. And t to the 0 is 1. This is 1, right? So the answer for this is 6t square minus 6t minus 4. Okay, now let's look at number 3. Function g of x is equal to x squared multiply 1 minus 2x. Let's just simplify this expression first. And so this is going to be x squared minus 2x cubed, right? So now what we have is derivative of this function g of x is going to be same. Looking at this is applying the power rule here. Here we are applying the constant multiple rule and the power rule, right? So derivative of x squared, I mean you see the thinking here, right? So I'm just gonna write the result instead of simplifying in details to save time. So x squared is definitely going to be 2x, right? 2 times x, 2 minus 1 is 1, minus derivative of x to the cube is what? 2, oh my god, 3x to the square. And what we have is multiplying with constant here, 2. So we have 2x minus 2 times 3 is 6x squared. Now let's look at this next function. G of t is equal to 2t to the negative 3 to the 4. Okay. So derivative of this function is equal to, again we can see here it's using this constant multiply rule, right? And so 2 times negative 3 over 4 t raised to negative 3 over 4 minus 1. This is what we are left with. Now let's simplify this expression further. As you can see, 2 to the 4, right? So we can simplify this later. So it's equal to negative 3 over 2 times t. So let's just simplify this. Negative 3 over 4 minus 1 is equal to 4. Negative 3 negative 4, which is negative 7 over 4. So t raised to the power negative 7 over 4. This is your answer. Okay, let me rewrite it. This looks a bit confusing. Okay, let's look at this number 6 as this function as of p square root of p minus p. I mean, I will simplify this like this. Square root means 1 over 2, right? I mean the other way of writing this. Okay, let's find the derivative of this function is going to be, again we are applying the power rule here, 1 over 2 p to the 1 over 2 minus 1 minus power rule, right? This is basically p to the 1. So the derivative of this is going to be 1 times p is p and then 1 minus 1. Okay, again simplify this a little bit, 1 over 2 minus 1, this is 2, 1 minus 2, negative 1 over 2. minus anything raised to power 0 is 1. Okay, so the other way of say, since the expression was in original square root, so we can again put this back in its original position, 1 over 2 under square root of p minus 1. Okay, let's look at the last problem, number 7. This function is equal to 3 times e to the x plus 4 over 3 times square root of x. Okay, now we can already see a natural exponential function here um, with constant multiple rule, and here we can see power rule plus. Okay, so let's find the derivative of this function, or we can simplify this as we have done previously. So this is equal to 3 e to the x plus 4. Oh, my bad. This is cube root of x, not 4 over 3. So cube root of x. Another way of writing this is x to the negative 1 over 3. Alrighty, so let's find the derivative of this function is equal to natural exponential function. Derivative of natural exponential function stays the same. So I'm applying the constant multiple rule here. So this is going to be again 3 e raised to the x plus we have this here going on. So this is going to be again constant multiple rule here. 4 times derivative of this is going to be 4 times negative 1 over 3 x raised to the negative 1 over 3 minus 1. This is equal to 3 e to the x. Let's simplify this expression on side. Minus 4 over 3 x raised to the negative 1 over 3 minus 1. So this is 3, negative 1 minus 3, negative 4 over 3. X to the negative 4 over 3. And here is your answer for this one. Okay, I really hope this helps, and let us see the patterns instead of just simply memorizing it or getting confused when we see functions like these or either these. There's always a simple way of doing things. So yeah, thank you.